A very good afternoon to one and all. This is Muthu Ramya, Research Scholar, ECE Department, NATPY. I welcome you all for the third session in day 2 of 5 days national workshop on advancement in antenna engineering using artificial intelligence. We have an eminent resource person, Dr. A. Prakasa Rao sir, with us. Dr. A. Prakasa Rao sir obtained his bachelor degree in ECE from Nagarjuna University, Andhra Pradesh, India, and master's degree in ECE from Pondicherry Engineering College, Pondicherry, India. And he obtained his doctoral degree from National Institute of Technology, Warangal, India. He has more than 22 years of experience in teaching at various organizations. Currently, he is serving as Associate Professor in the Department of ECE at National Institute of Technology, Warangal, India. It's about 20 papers are at his credit in international and national journals and conferences. His area of interest include signal processing, smart antenna systems, and optimization techniques. He is a life member of ISTE and also a member of IEEE. There are 40 UG and PG projects completed under his guidance, and currently he is guiding 2 research scholars. He has organized and conducted about 6 faculty development programs and served for many administrative responsibilities in institute and department level. He has been an invited speaker for several programs at different universities and engineering colleges. He has attended 1-month training at Signal Processing Laboratory, University of Southern California, Los Angeles, USA. He has been a reviewer for a few SEI journals. We welcome you, sir. Now I request Dr. A. Prakasa Rao, sir, to take over the session.
Thank you, madam.
Thank you, sir.
Thank you, madam. Thank you. Right. Good afternoon to all. I'm very happy to see you through online, attending workshops through online in this COVID situation time. We have to appreciate your interest to learn new things through online. So before going to see the detailed versions of optimization techniques in antenna beamforming, we'd like to see this term, optimization technique. The term it gives you is an old one and familiar one, and from the title itself you can understand what does it. In day-to-day life, we are using, knowingly or unknowingly, these optimization techniques in our day-to-day job. To discharge our actions and our works, these optimization techniques are used. I hope that you understand the role of optimization. Those who are using optimization techniques in their work, they are going to complete their work in time more effectively and efficiently. If you are not going to use these techniques in the day-to-day life, then they are going to face so many problems. Not only in a technology, these techniques are going to be used in engineering and non-engineering sectors. That is the reason this word is very crazy, optimization techniques. Now we are going to focus optimization techniques in antenna beamforming. How to use these techniques and what is the significance of that, why you have to apply these optimization techniques. All these things we are going to see one by one, and today and tomorrow section also, continuation of this. My outline is follows like this: motivation, problem statement, introduction, organization of the topics, and we are going to see n number of algorithms: LMS, GA, DE, Taguchi, TLB, DOA, PSO, and so on. Based on the time, we would like to cover these algorithms. Then finally, we have conclusions and references. Then the motivation, you can see that in the top corner, we have a dipole and it radiates signal in the other directions. In certain applications, especially finding objects where it is and all, searching operation, people are going to use, to radiate the signal in all directions. And for all India radio and to transmit the signal in all the directions, people are going to use this type of structures. And you need to radiate signal in all directions. And you can see here, this is meant for sector wise, you are going to cover the entire mobile region is going to be divided into sectors. Geographical area is divided into sectors, and we are going to arrange the antennas systematically to cover those sectors. So based on the application, we have to pick up the antenna and you have to do. Here the signal is radiated in all the directions, but point-to-point communication, we don't want to use all direction radiation. It is energy wasting. So based on the application, you have to pick up the suitable one. Then you have to see that at the bottom corner, right corner, we have array of elements and huge structures is meant for to probe the space, to study the space and all. So based on the application, you have to select the right geometry, and you have to have a proper coordination among the elements when you are using the array. Then you can see that in example 1, it radiates signal in all the directions. But when I'm going to use antenna, in particularly in mobile communication or point-to-point communication, we don't want to radiate energy in all the directions. It's a wastage of energy. But when you go for here, in a directional antenna, when you're using, energy is focused in a desired user. So based on the application, you have to select the proper antenna. That is very, very important. Simply if you're selecting one antenna, connecting is meaningless. Then you can see that here you have a good control on the radiation pattern. The main beam is focused towards the desired user, and where the interference is coming, you have to identify with the help of the algorithms, and you have to place the null in that particular direction so that we can have a better control on the radiation pattern. We'll get the better signal. Otherwise, interference will dominate. So once the interference is increases, then we need more power. Then that will lead so many other problems. Interference will create. So you have to be very careful to handle this pattern more effectively. So for that, we are going to use optimization techniques, how to handle this pattern more effectively, and how to control the side lobes and nulls, and how to steer the main beam and all these things. So our role is here how to have a good command on the beamforming using optimization techniques. Then when you go for smart antenna beamforming versus omnidirectional antennas, one has to know the importance. Otherwise, it's meaningless to study this. So we'll get it a high gain using beamformers, and that will improve the coverage area, because the gain increases means automatically coverage is going to increases, and less number of antennas are required to receive the signal. Then another one is side lobe cancellation and null steering. So with the help of this, we can have much reduction in the interference, and that will lead signal to noise is going to be improved, and finally channel capacity is improved, enhanced. My channel capacity C is equal to B log 1 plus S by N. Is familiar in a communication. So as SNR is improves, the channel capacity is also going to be modified, and will get a better or improved capacitance. Then with the help of the directivity sending information, the battery life is going to be saved and less energy is required when you are focusing directly point to point. So no need of more energy. Then using the beamforming, we can get the capacity, and you can improve the system capacity when you are using the SDMA technique, space division multiple axis. We have the different multiple axis in satellite communication. People are well known and familiar with how to handle the frequency and time and both time division multiplexing, frequency division, and CDM and all. But here we are going to utilize the space, and with the help of the space division, we can get the multiple axis, and that will improve the capacity. And we can have a frequency reuse with the help of the n-fold diversity gain. And not only that, we can get it multipath mitigation. So once if it is a direct connection, then delay spread can be controlled. And this feature is going to be used in radars as well as the mobile communication also. And once they have a good control on multipath mitigation, then the signal quality increases. The reason is when you have in the echo or reflected path, and that will disturb your spectrum characteristics, magnitude as well as the phase, because you received the direct signal, simultaneously you have received the reflect other directions also from other paths. So those have different gains and different phase delays, and all together when it is added, and we have some what you call phase distortion or amplitude distortion. So we can minimize with the help of these features, and finally can improve the signal quality. Then this can be used, the beamformers can be used in a MIMO platform, and also can be used in a radar applications. And the other one is enhance the geolocation. And to enhance the geolocations for GPS purpose, we need to estimate the angle of arrival and direction finder. So with the help of beamformer, we can improve the estimation, angles, and direction finding. So with that, we can enhance the geolocation more effectively. Then we have the 5G and 6G communications, and we are going to see the futures. And you know that the importance of the 5G and 6G. Right now, you are seeing many organizations are delivering their lectures through the online. Institutions, companies, businesses, everywhere, many are. So they are online. So when they are doing all the activities through online, then a lot of demand and a lot of data speed is required. That is the 5G. That is the 6G. So using, if you take the first generation, second and third, and before that, we don't have so many features and all. We have only limited features and all. In 1G, only voice, and 2G data also can be transmitted, and 3G we have the voice, data, and other internet facilities and email services and video conferencing, other facilities and all. So when you are going one generation to another generation, when you are providing more and more features and lot of to meet this traffic and all, and to provide a good quality of the signal to the customer, we have to provide your data rate is 10 gigabits per second. Your speed should be very high. Then only we can provide a good quality of the signal. If the people are demanding a lot of services, and they are exchanging the data between the points, but your traffic is your speed is very less, means they are not going to be happy with all these features. So one has to concentrate the speed and capacity. You know that's the importance of the speed when you are downloading the content from the internet, and your browser or your cable is unable to provide such speed, then you are going to irritate. So you know that is important of speed. Then the capacity, you have to provide more capacity, and low latency. This is one of the another important parameter, especially when you go for the driverless cars, and there the demands latency is 1 millisecond or sometimes less than that, uh, because they have to take the decisions instantaneously. Your car is highly sophisticated with this equipment, smart antenna and other sensors and all. They have the proper integration among them. They will sense it, and they have to process the signal, and based on the signal processing, and they have to take the decision instantaneously. So the latency when you are transmitting the signal and receiving back, and the delay should not be much. So it should be less than 1 millisecond. So these are the possible with the help of the 5G communication or beyond 5G only. And quality of the signal should be simply you're giving, but there is no quality. It's meaningless. So you have to give the good quality of the signal. Then the bandwidth, uh, it is 1,000 times higher it will provides. And the battery life, especially in IoT applications, your IoT, generally the system is very compact and small, and less power is demands, and the batteries are frequently demands recharging. So one has to recharge, or you have to increase the size, but it is not possible. So when you're using the 5G and beyond that, and because we have a point-to-point connectivity, and with that battery life can be extended, and similarly coverage area is also possible up to 100%. So these are the salient features why you are going for the 5G and all. So simply if you are provided the link, but there is no quality, it's meaningless. Normally you can see that you are offering something, but it is not eatable, then it will go to the dustbin. So there is a meaning of that. So once if you are offering, that should be eatable way, and the quality is very important. Simply offering item, and if it is not eatable, is meaningless. Similarly, and speed is less, and the capacity then is a meaningless. Meaningless. The people are not going to happy. They are not going to use these services and all. So we should know this importance of these parameters. And when you want to satisfy, one has to move to 5G or beyond that. Then applications, driverless cars, healthcare, robotics, industrial, etc., etc. Then we have this will provide extraordinary data capabilities and high connectivity. So with that, we can so that the lifestyle is going to be changed. And now you can no need to go to the bank, and you can do the your business. You no need to go to the shop. You can do through online. No need to go to the company. We can do your business through all these things can be possible. So how to utilize the technology, that is very important. So if you are going to use the technology in a more effectively, then we can get the more and more revenue, and we can provide more facilities to the customers. Then we are going to see that approaches, classical methods, evolutionary techniques, and hybridization. We are going to concentrate these things. Then what are the optimization techniques or heuristic algorithms are available? If you go to the literature, n number of algorithms are existing, techniques are available. Out of that, I have listed few, and those who are interested, we go through that and get it more and more information in this direction. So here you can see that differential evaluation, then genetic algorithm, particle swarm optimization, spider optimization, ABC algorithm, then ant colony, monkey algorithm, butterfly, bat algorithm, and so on. Taguchi, BBO, teacher learning based optimization technique, wolf optimizer, butterfly optimization, then cuckoo search, raindrop, then simulated anomaly, a genetic algorithm or programming, then fish algorithm, bacterial foraging optimization, then evolutionary programming, evolutionary strategy, like that. A number of techniques are available in the literature. My idea behind this slide is, from the slide, if you go through this all these optimizations, you can get a one common point, and that is all these algorithms are based on the nature phenomenon. So if you observe the nature thoroughly and closely, and if you watch that nature and your surroundings here, then we can get a ideas, and based on that ideas, we can also develop the new algorithms. You can see that butterfly, bat algorithm, ant algorithm, how the ants are doing, then cuckoo search. So all algorithms are, you can see in the nature how these are moving and how they are how effectively they are doing their activities, and from that we can learn, and those techniques we can apply in this direction. So you have to motivate your boy, ask them to observe the nature very closely. So when they're going to observe the nature closely, then they can get the new ideas, they can develop the new algorithms also. So then after developing new algorithm, how can you say that the new algorithm is correct and all? So to get the credit when you are writing the paper and all with your algorithm, and they will ask whether it is effective or not. So that you have to test it, your new algorithm on few of these test functions. You have to pick up half a dozen at least, then you apply on them and see the performance and all. Rosenberg, the spear function, Bluetooth function, any of them. So based on the problem, you pick up and test it and see that the performance of the algorithm, how it is works. Why I'm asking means, here uh, I don't know whether your algorithm is good or not, and the people are very familiar with all these test functions and all. And if you refer the literature, they will say that the algorithm is develop this similarly, and you can compare the results, and you can say that my algorithm is taking less time, or it is giving a better cost function, like that you can compare, and so that people will appreciate, and you can get the quickly acceptance rate. Otherwise, if simply if you take the GA and if you write your code on your problem, and if you publish, and they'll tell is already is a number of people are worked, and what is your novelty. So when you want to develop the novelty or some modification and all, simply looking only existing techniques are not helpful. So you have to observe the surroundings, and you watch it carefully and thoroughly, and from that observations we'll get the ideas, and with that ideas and what you studied so far, existing algorithms, and you can fine tune, and you can develop the new algorithms also. So like that you have to motivate your boy, so that they will appreciate. So you have to explore their inherent qualities. Simply what is there in the textbook and delivering is not a great job. That is also important, but along with that, we have to motivate the boy to identify his skills. So you ask the in that way, and they will observe the how it is. Then from that they will get the ideas. They will incorporate the ideas in this existing algorithm, and they will modify. They will improve the performance. That iteration wise or error wise or computational wise, what are the parameter. So from that they can get the good credits. So then you have to see that in the present uh, in the 21st century, the modern wireless communication services are spreading rapidly every day. The features are increasing. Decades back, during 1970s or that time, or even 80s also, 90s also, we don't have the cell phone and all these things. One has to go to the telephone booth and they have to book the call, and when the time comes, he has to answer, and sometimes he may not get, again he has to go back, again he has to wait, and all these things. Uh, so this is the time taking process. But today, uh, uh, today you can see that, hello, is getting signal fine? Hello, anyone can respond? Is it audible?
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
right,
You can
right,
continue,
right,
sir.
right. Yeah, right, right. So I'll continue. So now you can see that uh, in a day to day, the services are features are increasing, and due to that, the electromagnetic field around you also is increasing, and a lot of pollution is there, and one has to concentrate, and due to this electromagnetic field, the nearby cell is going to be disturbed. So that we are going to call it as a pollution of the electromagnetic field environment is going to be increasing rapidly. So one has to concentrate how to minimize, otherwise interference will occur. So adjacent cell is going to be affected by the other cell. So that should not be happen. We don't have rights to disturb the other. When you are, say for example, when you are taking the class, you should not disturb the other classes. You have the energy, more energy, and you are shouting and you are taking the loudly is a fine. Your intention is that the last boy should be able to hear. That is good, but you are taking beyond that energy level, so not required. So that should not be affect the other classes. So similarly, when you are radiating the signal in your boundaries, it should be within the boundary, but you should not go to another boundary and not to disturb the other users. So these are the things very important. So one has to control that pollution. So for that, we have to concentrate how to do that and all. So so many techniques are available, and it is going to be widely used in military, radar, and sonar, and mobile communication to reduce the effect of desired signal interference on the surrounding systems. So a number of techniques are available, and it is going to be used in radar, mobile communication to reduce the effects of undesired signal interference on the surrounding. So normally when you are when you are taking class, if you are getting signal, unwanted signal coming from the corridor, then what you are going to do? You are closing the door, or you are closing the curtain or something like that. So when you are doing like that, to some extent you are controlling the interference. Similarly here, I need to control my radiation pattern effectively, so that to minimize the interference in that system. So here, the smart antenna system uses evolutionary algorithms, which not only maximize the signal power in the desired direction, but also places nulls in the unwanted or undesired directions to minimize the interference effect on the system. It's very simple. So we are maximizing the energy in a particular desired direction, desired user direction, and at the same time we are going to place nulls in unwanted direction, so that interference can be minimized. So this is the thing we are going to do in coming slides, how to handle and how to do this. So hence it is called as a beam forming. We are going to handling the beam. So to find the solution in this direction, we have many analytic techniques are available. What are that? Woodward-Larson method, Taylor's method, if Fourier transform techniques, Dolph-Chevsky methods are available. It can be used. If you go to any standard textbook, antennas by Cross and Jordan and Ballman and anything, those standard textbooks, we can get the these techniques. With the help of these analytical techniques, we can get the solution for this problem. But when the desired pattern is keep on changes dynamically, if it is changes, then we need to compute again and again. So it takes much time. So to avoid this, one has to go for some another technique, and that technique is called as a optimization technique. Okay, so we are going to use these techniques not only in that in a question pattern, in a pencil beam, in sector beams, to control the nulls and side lobes more effectively. Then we can see that traditional methods are not efficient to obtain the optimal solutions. So you want to get the solution quickly, because user is to keep on changing. So if you take the mobile communication, the user may be at 60 degrees. After a few seconds, he will go to maybe another direction, another angle. Then you need to rotate the your beam. Sometimes not only in the cell, he will cross the another sector, and immediately you have to take the handoff techniques, and you have to give the immediately the link. So you have to keep you have to observe the his movement, and accordingly you have to adjust the radiation pattern. So that is not possible instantaneously by using traditional methods. We can do, but it takes much time. It is not efficient. So one has to go for some other techniques. Those are called optimization techniques. So with the help of the optimization technique, we can get it quickly. So now, in a modern technology, the spatial beams are widely used in satellite and radar applications. We are going to use the different shaped beams, not only the pencil beam, sector beams, and question patterns, and based on the user demand, then we have to adjust the pattern. Then what are the traditional and the classical methods? Steepest method, Newton's method, and LMS, least mean square algorithms, and all these things are we are going to use that. But here, first two methods requires the estimation of the gradient for on each iteration. For every iteration, by iteration, we need to compute the gradient, and then you have to get the optimal results. Whereas the LMS algorithm doesn't require any repetition gradient estimation, and it is a simple and faster. We are going to see the detailed. Don't worry. So one by one we'll see that. So it is a simple and faster compared to other two methods, steepest and Newton's method. Then we can make a conclusion at this stage. LMS algorithm is very simple and easy to implement, but it has it may stuck at a local minimum, and the convergence also depends on the step size, and sometimes it will be slow also. So it depends on the step size, convergence will be slow. So what do you mean by LMS? Least mean square algorithm. We are trying to minimize. We are trying to minimize the error between desired and actual output. I got the actual output, and I'm not happy with this actual output. Then we are trying to get it the actual output closer to the desired. So to get the desired output from the actual output, we try to compute the error, and we try to make the square of that, and we are trying to minimize this error iteration by iteration, so that we will get the desired pattern. So hence it is called as a least mean square algorithm. So it works on minimizing the mean square error between the desired output and actual array output. So you got the array output, and you have the desired output, and we are trying to minimize the error by iteration by iteration. Finally, we will get the desired output. Then you can see that beam forming structure, the block diagram. Partially, this one is partial one, not complete one. We are going to receive the signal by this array. The output of this array is not directly connected to the output of the system, not to the adder, and in between this signal is going to be weighted by these weight vectors. So before going to add the signal, you are going to adjust by using these weights, And these weights we are going to compute with the help of the optimization techniques, and we have some feedback mechanism. So the output of the signal is fed back. uh, Output of the signal is fed back to the uh, optimization technique. Here we have the sophisticated digital signal processing is existing, and the output of the signal processor is connected to these weights, and these weights are going to be controlled properly. Are you got the point? Or so finally we'll get the desired output. We'll get the desired output. So to get the desired output like this, we need to adjust these weights, and to adjust these weights, we have to observe the output signal, and you have to compare the error, and we are trying to minimize the iteration by iteration error, and at one moment we'll get it desired output. So how to notice that you got the desired output? The error is closer to 0. So once the error is closer to 0, we'll ask the stop the further iteration. So at that stage, what are the array weights are available? Those weights are going to be fed to this network as a final one. Then finally we'll get the desired output. So further there is no modification in the weights. Then you have to see that applications of beamforming techniques in different areas: radar, sonar, communication, imaging, geophysical exploration, astrophysical exploration, and biomedical. So we can see that how to utilize these techniques in that, especially in our domain. Then the introduction, you have to see that the overview of the antenna parameters. The boy should have a good command on these antenna parameters, because he has to define the cost function, or what you call error function or objective function. So which parameter you want to control and all. So for that you should have a clearly all these parameters overview. Then control parameters to get the desired pattern. Which parameter you need to control. So you have to see that to shape the overall pattern, what are the control parameters are involved. Then you have to see the synthesis techniques. Then smart antenna concept. Then these are the few parameters. Already boy has studied in a third year level, and when he's going to use in his project, so they have to concentrate all these parameters: radiation lobe, directionality, omnidirectional patterns, then directivity, gain, efficiency, beam width, polarization, all these things. They should have the good command on this terminology. Right now I'm not going to touch. Then this is the typical radiation lobes and beam widths of antenna pattern in a Cartesian coordinate system in XY plane. Then on x-axis is angle, and in y-axis you have a decibel level, signal strength. Now this is the main beam, and these are the side lobes. So especially in our radar application, or in a mobile communication, certain case we need to control these side lobes, and we need to place the nulls in forcefully at a particular side lobe. So this is the main beam, and these are the side lobes, and this is the back lobe. And you can see that this is a field pattern, uh, this same Cartesian coordinate system in the field fashion, and this is the power pattern. So from this you can get the up power, beam width, and first beam width between the first nulls, and all these values, and what is the side lobes, and what is the back lobe radiation, everything you can visualize here. Then the single antenna is a from that you can get the gain is relatively it is low. We can get the low directivity or gain, and we have the wide the radiation is relatively is wide. Is it clear? So for our transmit the signal for the long distance communication, we need high gain. So normally you can go to in the classroom, we are going to deliver at a one level of energy, but I can't go for the same energy level in the auditorium. I have to shout. Even if I shout also, it is not possible. I have to use some another mechanism, some electronic system, public addressing system. With the help of that I'm doing. But if you want to transmit the signal from auditorium to maybe some long distance, then we have to use some wireless technology. So it depends on the problem. We have to find the suitable mechanism. Well, now I'm going to concentrate what type of antenna structures are required to radiate the signal for a long distance. So here, to transmit the long distance, we need a high gains. That is obvious. For how to get this high gains, so the solution is how to increase the electrical size. If you increase the size of the structure of the antenna, then you can get the more gain. But practically, it is not at all advisable. So one answer is enlarging the size, but the other one is the array. So array means a small unit is going to be repeated, and you have to arrange in a systematically, and among them you have some networking, proper feeding will be existing. With that, you will get the desired pattern, and you can communicate for a long distance. So here we need to control the these weights. If we are going to adjust properly, then you can have a good control on the radiation pattern. Then what are the control parameters are there to shape the radiation pattern? So here n elements are considered. So we have five parameters to control the pattern. One is the geometry, the other one is the inter-element spacing distance between the elements, and IE stands for amplitude, either current or voltage, and alpha, this is the phase, can be controlled, and element pattern. So geometry means you can choose a linear or a circular or a triangular shape or planar pattern based on the application. We have to arrange the elements in a systematically in the plane. So okay, so using that also you can get the you can have a control on that. The other one is spacing between that. It may be constant or a non-uniform. So constant may be zero point 0.5 or a non-uniform 0.5, 0.25, 0.75 randomly. So how to choose that randomness? So again, our optimization technique plays a role. Similarly, current and phase, we need to adjust the simultaneously both or sometimes any one of them. So how to adjust the your magnitude, either voltage or current. So you want to give 0 millivolts, zero point 0.2 millivolts, zero point 0.5 millivolts, or like that. So you are feeding using the phase shifters. What should be the signal strength, and what are the parameters to get the pattern? So we need to control. Then element pattern, you have to select the shape of the antenna, either parabola or hyperbola or ellipse or elliptical shape or a dipole, or based on the application, or wire antenna, so patch antenna, fractal antennas. So based on the application where you are going to install antenna on the system, so accordingly you have to select it. So in the laptop, the type of structure is different. In the cell phone is different. If you go to the airplane, aircraft, then they will provide the specific area in the nose of the aircraft. There only how to install, or in the wings. So they will specify this is the area we are providing. Other places it is not possible. It already is packed with the power systems, other motors and all. So you do it. Then you have to design accordingly. So we need to control these parameters, and you have to do it properly. So for that, we have to do that trial and error method. But going for trial and error method, it takes much time. So one has to use the optimization technique. With the help of the optimization techniques, using equations and all, then we can do it quickly. We can find the optimal solution for that antenna structure for that application. They say, for example, for antenna design for air navigation or air traffic control, and they gave us a 10 days time. These are the specifications you have to follow. If you go for trial and error method, that 10 days is not sufficient. So if you use the optimization techniques, you can do quickly, and you can finish it off your task within a time. So that is the significance why you are going for the optimization technique. That is one example. Similarly, n number of applications you can find. Then this already you are seeing the definition. Then you have the model and optimization, adaptive beamforming algorithms, and direction of arrival estimation. Now you can see the linear array geometry. The elements, n elements are arranged in a linear fashion, and the output of this system, array output y of t is equal to your incoming signal x of t is multiplied or the product of your weight vectors. So we have some production multiplication among these two vectors. So here we have to see that LMS algorithm applications where it can be used in a signal system and filtering problems and smoothing application prediction and like that. So unknown plant to identify the system. Then you can use the equalization to you can develop the model for your channel. So inverse model you can develop. Once you study that, you can develop the inverse model. Prediction, what is the next value, the random nature of that system. Then echo cancellation, undesired signal can be removed, can be nullified, can be minimized to some extent with the help of echo cancellation. These all these techniques in that we are going to use LMS algorithm. What do you mean by LMS algorithm? It is nothing but number gaming. So you can recollect your childhood, and people used to play the number game. The 4 or 5 members will be involved in the game, and one boy will pick up the coin from the box, and he has the rights to see that coin. So he is going to open and he will see, and the number may be say 10.5. Then that boy will ask the what is the next what is your guess. That boy will say 1. Then this boy will say no. Then again we'll give chance to other boy. That fellow may say 20. Again we'll say no because it's wrong. Then again it goes. So after a few iterations the game will end, or sometimes may never be end. So sometimes it will over by first iteration. The boy said 10.5 is over, game is the first iteration. So it depends on how is going to be guessed. It may be 1 iteration or 10 iteration or infinite iterations. But if you go to the optimization technique with the less combinations, we can get the output quickly. So here in the number gaming, I'm going to give the few more rules and regulations how to play the game. Earlier there is no rules and regulations, so this keep on going. They don't know what is the starting number, what is the end number. Only the person who knows that he holded number 10 says him that he holded 10. Then they started 1, 7, 5, 20, 100, 1000, like that is going on. There is no boundary, simply is going on. But next again he has given some boundary. My input is minimum value is 1, the maximum is 100. So now the players will restrict their guessing between 1 to 100 only. So it will going to be over your game by maximum 100 iterations. Okay, the next time he has given some information about in which direction you are, in the downward or upward. In the two games there is no direction, randomly is going on. The next he has holded 10, he asked what is the number 1, then you are in the downward direction. Then your boy will go to 20, then you are up direction. Now the boy will understand this search area is restricted 1 to 20. Earlier it is 1 to 100, and now he has given the direction. So with the help of the direction he has fixed the span now 1 to 20. So maximum 20 iterations it will be over. So in the first case infinite iterations, in the second case 100, in the third case based on the span. So if it is minimum and maximum is identified, then say if it minimum is 1, maximum is 20, maximum 20 iterations. Even then your search area is 1 to 100. So the next case he has given the step size. Are you got the point or not? So now he is giving the step size. So maybe step size is 1. So when he's giving step size is 1, he is at 1, and they said you are in the negative. Then he started 2, then 3, 4, like that is going, and every time he's giving where you are and direction. Then after 10 iterations, the game will be over. So he has it 1, 2, 3, 4, like that is step size is increasing, is over. And then if the step size is 5, just 2 iterations enough. So he has at 1, next 5, the next is 10. So this is and based on the error is adding the steps function and is going to predict the next value. So after few iterations, game will be over. The same logic is going to be involved in a LMS algorithm also. Now present value, your present value, your step value, and a difference error, whether it is a positive or negative. So according that, your step size is going to be added, and we will get the next value. So it is easy to predict the next value with the help of present and step and error signal. So this is actually is involved in the number game, the same thing. That is why in the beginning I said, if you observe the your surroundings and you will get the so many ideas, and you can develop the so many things. Or you got the point or not? So you have to motivate your boy to observe the your surroundings closely to get the new ideas. These parameters, this is very important. The boy has to concentrate. Convergence, cost function, rate of convergence, computational requirement, and robustness. So what does this meaning of these things and all? One has to be very careful. uh, what do you mean by convergence? Say you are developed the algorithm and you got the output and it's supposed to be 0. You are expected error will be 0. Fine. Your final output 0. And based on your algorithm, you got the value maybe 0.5. And your 0.5 is very closer to 0, and you are going to accept it. And you are going to say 0.5 got it, so it is converged. But actually, it is not like that. This 0.5 should be stable throughout the operation. Then you can say it is converged. Simply converged at one moment, and later on, first iteration you got 0.5, it is converged fine. And second iteration maybe 5, third iteration 10, fourth iteration 1, and fifth iteration 0, like that is. This highly is varying. Your output is varying time to time. Then how can you say it is converged? So simply I got the output, I expected 0, you got the 0.5, answer is converged is means meaningless. So you have to give an example to the boy, then boy will understand. So whether the value is stable or not. So I got first iteration 0.5, second iteration 0.3, fourth iteration 0.2, 0.5, 0.3, 0.1, 0.5, or zero point 0.1. So if you take the error between your expected and what you got it, the error is plus or minus 0.5. Then you can say it is a converged and it is a stable. But in the previous example, your error is highly random and the magnitude is very high. So you can't say convergence. Maybe at one iteration it is converged and later it is not converged. So you should be very careful. Then cost function. We have to define cost function because your performance depends on the cost function. In LMS, you are trying to minimize the error 0. So between desired and output. So you have to define the cost function. So if you define cost function effectively, and your performance of the system is depends. So you have to be very careful to define the cost function. Then the rate of convergence. You got the convergence value with the help of this cost function and all, but you should get it quickly, effectively and efficiently. So it has to take less time. So you got the error maybe 0.5 or 0.2, but after 1 millisecond, or after 10 seconds, or after 1 hour is meaningless. So the person who got it less than 1 millisecond is the good. So how much time is taking to get the optimum results. So the rate of convergence should be also one of the important parameter. Then computational load requirement. You got the output, less time and all, but how many iterations is taking, or how many operations are involved? Because based on that only the power of the power consumption of the system is decides. So you got the things, but how many additions, how many multiplications are involved in that operation? So the computation load is very important. According to that, we are going to design the hardware circuit. And then robustness. You are designed the algorithm, fine. You got it. You are using a efficient computational requirement. Rate of convergence is also good. Cost function is defined well defined manner, and convergence is also stable, and all parameters are good. But you are not concentrate robustness, then it's meaningless. For example, you are designed a circuit in the laboratory, and it is giving nicely gain, bandwidth, and input impedance, output impedance of the amplifier and all. Fine. But you are not taken certain parameters, and you are explained to the boy, and this will work. You will imagine that, yes, my sir has said it is works. He has tested in front of us also, he has demonstrated, so I can use in my practical application. The moment if he is going to connect it to the in a practical application, it is not working. Many reasons are there. You are tested only input impedance, output impedance with respect to what you are given, but you should address to the boy what should be the input impedance, what should be the output impedance when you connect it. Otherwise loading problems are there. And not only that, you are tested in the in a room temperature. Ambient temperature is room temperature, but when you take into the industry, the temperature is surrounding temperature, ambient temperature is very high, and your circuit may not going to withstand. So these are the issues you have to address. So and what about the noise? You are giving the signal, a very direct signal from the function generated to the your circuit, so there is no noise at all. So simply got the amplification. But when you go for practically, when the moment you give the signal from the microphone or some another sensors, it may absorb the surrounding noise, and that also is going to be amplified, and final output is slightly distorted. So you have to address the clearly. Your circuit should be withstand even in the noise environment also. So it has to work in it has to work at different circumstances, surroundings also. So you have to address to the boy the importance of this parameter, otherwise meaningless. So if you explain these parameters like this, then they will appreciate, then they will design more effective system. Then LMS algorithm, already you have seen this just now. Output is equal to product of your signal vector and weight vector, and error function is difference between these two, d of n and y of n, desired signal and actual output. And weight updation, this is the initial vector plus mu into signal plus error signal, sorry, into error. So that value will be added to initial vector, and the next iteration the value is going to be updated, that is going to be taken into account. And so this goes on like that. At one moment error will become 0. Once the error will become 0, your w of n, your n plus 1 next value becomes a present value, then the algorithm will be going to be stopped, because you got the desired output. So you are going to stop the next iteration. So that final output you are going to consider, and that values are going to feed it to the network. So here one has to concentrate this mu step size. As the step is very very small, just now I gave one example. You are at 10 and you started 1. If the step size is 1, you need to wait for 10 iterations to get the final value, to converge to that value. So 1, 2, 3 like that. If the step size is say 5, then just 3 iterations are over. Quickly it will be converged. Got the point? If the step size is very very small, it takes more time to converge. If step size is very large, it takes less time to converge. But what about the error? This is also another important thing. Say, for example, you are holded the number 10.5 for time being 10.5, and you say your step size is maybe 1. Then what is your error at finally plus or minus 0.5. So your started 1, 2, 3 like that will come 10. Then error is 0.5. Then next time is 11. Then again error will be 0.5. So the maximum is plus or minus 0.5. So when I'm using the step size is 1, uh, when you are using the step size is 1, the error is plus or minus 0.5. Assume that I'm going to take my step size is 0.5. Then 1, 1.5, 2, 2.5, 3, 3.5, and goes on like that. So at the end of the 21 iterations, then what is the next value? Is the 10.5, and your desired. So error will be 0. Are you got the point or not? So it takes more time, but error will be 0. So this is a advantage. If the step size is very small, the step size is very small, error will be minimized and takes more time. If step size is large, quickly converged, error will be more. So we have some trade-off between the step size, the error function, and the number of iterations taking to that. So one has to concentrate how to handle this and how to fix this trade-off among these parameters. Based on the applications, you have to handle this. You have to choose the properly. So again, the normalized LMS, this mu is function of your incoming signal. Here, this is not the function. You are going to fix it. Mu is equal to 1, mu is equal to 2, mu is equal to 0.5, mu is equal to 3. Based on your application, you are going to do that. But this is the function of your signal. So based on the signal, you are going to adjust. Automatically, it's going to be modifying. So sometimes your autocorrelation function of your incoming signal may be 0. Then if this small term is not there, then it becomes infinite. So that should not be happen. That is why we are going to add a small term, that is a gamma. So with this gamma, even if the signal is 0 and this normalized in the LMS algorithm, step function never enter into 0, never enter into what you call infinite. So this is another important thing for normalized LMS algorithm. Then you have to see that mm, certain applications, how to use this LMS algorithm, radiation pattern of linear array with number of elements 21. So your desired main beam is at 60 degrees, and undesired signal arrival is at minus 30 degrees. So now look at here, at exactly at minus 30, we have the deep null. You can notice here. And similarly, exactly at 60 degrees, we have the main beam. So we are tested and verified with different number of elements, n is equal to 21 and n is equal to 51, and how it is, and all the side lobes are below the desired levels. So like this, we can do that. And similarly, on another case, then this is the convergence plot. Now you can see that, see, when you go for these two, this is the standard LMS algorithm. This is the normalized LMS algorithm. So if you keep it side by side also, or if you look at these responses, we can't notice that which one is taking less time or which one is giving better performance and all, how it is converged and all. And those informations we can't get from the radiation pattern. So one has to go through that convergence plot. So with the help of this convergence plot, we can get the other details. Now we can look at here, the black one curve indicates the standard LMS, and dotted response is normalized LMS. So around 10 iterations are enough to get the convergence by using normalized, whereas standard LMS is required around 50 iterations. You may get doubt. So why can't you take 20? Yes, at 20 itself it is converged, but it is due to stuck at local minima. So this is stucking with the local minima. Your function may have so many minimas. So with that, it is going to be stopped. But later on, it will come out. So that is why I asked it in the beginning. Convergence is very important. It has to be converged throughout the operation. So if you magnify this performance, now you can see that it is came out at around 40 and 45. So after 50 only, it is converged. but whereas LMS after 10 iterations is almost constant. The convergence is good and it is stable. And initially we can see the highly random. Why means initial weights are a random nature. So we are not taken any predefined defined manner. So that is why error will be more, and you can notice that mean square error will be in the beginning is high. Similarly, you can compare with other cases. Then recursive least square technique. Uh, so to improve further, we are going to use the RLS technique. Recursively, we are doing. So the computational load is going to be minimized. So here you can notice that in this graph, so many minimas are there. These all are our minimas, local minimas, and these are the global maxima. But we have global minimum and global maximum only one. So where it is a global minimum, where this one. So this is the my global minimum. So look at here, near to the x-axis is my global minimum, and remaining are local minimas. So sometimes my algorithm may be stuck at here. So because you are trying to find the minima, and chances are there to stuck at here. So similarly maxima also, you can apply optimization techniques to find the minima or maxima, or what are the characteristics of the signal at particular location. So one has to concentrate least square techniques to improve further. Then these are the results when you use the RLS technique on a 21 element array. Then we can have the CMA, constant modulus algorithm, and we are going to use the communication features, because when you go for a FM, the amplitude remains constant. So most of the practical applications, when you are using the time reference signal, it is not going to be available. So we are going to use the CMA modulus technique to find the signal, and you can start it. Okay. So practically most of the time the reference signal is not available in wireless communication, but you have the characteristics of the signal. With the help of that you can proceed, and amplitude is almost constant. Using this algorithm we can do that. So these are the outcomes by using the CMA. Then in the circular array, one has to get the array factor is like this, and we need to control the W of n. Then this is the radiation pattern by using the circular array, and RLS and planar array. So you have to arrange in x direction and y direction. This is the x direction array factor, and this is the y direction array factor, and you try to multiply. So already you have seen the linear array and x direction. Similarly, get the array factor in y direction and multiply them. That will give you that will gives you planar array array factor. So once you got the array factor, you can control the weight vectors with the help of optimization technique. And this is the radiation pattern for 21 by 21 planar array. So you can notice that main beam at 40 degrees, and unwanted signal is at minus 60 degrees. Slightly deviated. Okay, it is acceptable. You can't, because it's optimum means you are going to accept it. If error is less than 5%. Sometimes it's now it is less than 1% only, so you can accept it. So that is the meaning of the optimal. We are going to get the results effectively and efficiently. So no need of exact value, so not necessarily, because the title is itself optimization, so you are going to accept it with the acceptable error. Then these are the different case studies. Uh, then this is the tabulation. So you have to enter side lobes and all the graphs. From all the graphs you can enter all these things, and from that you can have a idea which one is giving a better one, and all these things. So one has to develop the things, side lobes, then up or beam width, null position, and all these things you have to enter. Then to improve further, you have to go for another domain, that is kernel-based LMS. We have to explore future space. So you have to translate or you have to estimate your weight vector in a future space, and all the steps are similar in both the case. LMS and kernel-based LMS steps are more or less same, except the future space. So with the help of this future space, we can compute more effectively. So you can use here kernel Albert space in the future space, and with the help of that we can adapt the value. Now we have to go for genetic algorithm. Genetic algorithm. Now look at here. It is a global optimization technique, and it is going to be used in n number of applications, and especially to overcome the local minimas and all, and to understand the algorithms easily, people are going to concentrate genetic algorithm. Okay, and now we can see that we can also have a hybridization. LMS and GA can be hybridized, and we can explore the features of the LMS and GA, and both can be utilized simultaneously, and it can improve the performance. So already I've seen the LMS concept and block diagram. Then these are the steps involved in LMS, and what are the steps involved in the LMS algorithm. So you have to define the parameter D between the inter-element spacing, distance between the two elements or successive elements, then n number of elements, desired signal direction, undesired signal direction, then step size, all the parameters, side lobes, bandwidth, then number of iterations. So you have to define. Then you have to construct the input signal and your noise environment you have to define. Then update the weights with the help of the error function. Then you have to check that whether is error is 0. So once it is error is 0, so you have to terminate it. So you'll come out from the loop. Then you have to stop the further updation of the weights. Then you have to take those array weights, and with the help of that array weights, you are trying to plot the array factor with the help of the plot commands. So these are the 6 steps involved in algorithm. Hardly some 30-40 lines will be there in the programming. So you can do easily. You can motivate your boy and ask them to do it. Then a genetic algorithm, it is a heuristic search algorithm. What do you mean by heuristic? Heuristic means possible solution candidates are going to update by themselves if the performance is not good, by iteration. So the present solution candidates will test themselves what is the output, whether it is above the fitness or below the fitness or where it is and all, and if necessary some operations are going to be applied on that, and accordingly the caches are going to be modified, and from that we'll get the desired output. So the values are going to be updated by iteration, hence it is called heuristic search algorithm. What you got the point or not? Here we can give the one example. For example, you are selected team members for a particular task, but among them you need only few candidates. You selected maybe 100 initially, but you need only 5 students. So how to get this 5? Again you are going to filter it. You are going to conduct some tests and all, and those who are got from threshold above marks you are going to accept, and below the threshold mark you are going to discard because their performance is not good. So once they are qualified your threshold level, and you are going to take it, but those are not your satisfied level. But what you are going to do, you are going to do some training, do this way, that way and all. You are going to explain one more time, or some training you are going to give. So with that training, what happened, their caches are going to be modified, and if you conduct the test now, the performance is going to be improved. Again, you are not happy, again you are going to train them. So every time the candidates are going to change their behavior to perform in a better manner. So iteration by iteration, the performance is going to be improved. In case if the performance is not going to be improved by iteration, you are going to discard. Say you are selected 50 from the 100, then you are conducted some test, and if they are doing well, you are going to take the next level. If they are not doing, then you are going to remove a few of them. Again, you are out of 50, some 30 you are going to take. From 30, again 20, like that you are filtering, and every time you are tuning. So you got the point or not? So if they assume that after certain iterations, if they are not performing, even if after training, then you are going to change the again entire team. Again you are going to start from the beginning. So this is the things will goes on, like. I got the point. So it provides efficient and effective technique for optimization. Steps involved in GA: chromosome construction, initialization, selection, crossover, mutation, and termination. Okay, so mutation, crossover, and termination. So we have to see one by one. Uh, this is one of the important thing: construction, chromosome construction, and the generation of the initial population. So your entire performance is depends on your initial population, and you have to initialize population properly, and you have to construct the chromosome. So your selection process is good, then you will get a better results easily. Otherwise, you need to struggle. So after initializing, you have to identify whether they are fit or not. So with the help of the fitness function, we are going to do that. Then once if it is over, this step is gone, then you have to go for a selection process with the help of the rank or Boltzmann, one of the technique, wheel technique, roulette wheel technique and all, or entropy technique, or tournament technique. With the one of these technique is going to be used to select it from this fitness. So once we got it, selected one, but may not be desired one. So compared to initial, these are good. Okay, then you need to fine tune it. So you need to modify further. So you have to apply the crossover and mutation. So by applying crossover and mutation, you will get the new generation. So initial generation is called as a old generation, and after selection process, if you apply the operation crossover and mutation, you will get the new construction chromosome, and those chromosomes are called as a new generation. If the new generation is good and if it is giving best results, you will stop it. Otherwise, you are going to repeat it. So these are things. Right now is almost end of the today's section. So we'll continue tomorrow. So before going to stop, let me know any doubts up to this level. So tomorrow we'll continue from this slide. So please let me know any questions, any doubts.
Thank you, sir.
Okay, madam.
Participants, can I ask your questions?
Any
You can
questions?
even post your question in chat box.
Yeah, even in chat box, no problem. Any questions? Nothing. So tomorrow you are going to ask? No problem.
Yes, sir. Sir, please suggest any books.
Okay, madam.
For the
Tomorrow
study and
I'll suggest, madam. Tomorrow I'll give you a list of the books. Okay, madam.
Okay, sir.
Okay, madam.
Shall I conclude, sir?
Actually, I have the meeting at 4 o'clock. So
Okay,
that is the
okay.
reason I have
Okay,
stopped.
sir.
Okay, madam.
Thank you so much, sir. You can leave,
Oh,
sir. Thank you so much.
okay, madam. Right, madam. Right. Thank you. So, okay, we'll see tomorrow at
Yes,
the same time. Okay, madam.
yes, thank you.
Right, madam. Right, right. Right.
Now, now participants can join the next session, fourth session, which is a fitness session at 4 o'clock. Thank you.